Thank you so much, Joseph. And as he said, as you're probably well aware, please do get involved after the speeches with some questions online, which Joseph will chair. Now, just a change to the program that has been online. Gavin Gillett from Rio Tinto can't join us. We're going directly into the speech by Serkan Saydam, Professor and Director of Research at the School of Minerals and Energy Resources Engineering at the University of New South Wales. Very late over there for them. He is also the Deputy Director of the Australian Centre for Space Engineering Research. Welcome, Serkan.
Thank you, Lisa. And hi, Joseph and everyone. Thanks for the opportunity. Can you hear me okay?
Wonderful. Lovely hat collection behind you there.
Yeah, thank you very much. So it's my home office, so 9:30 p.m. in Australia now. It's not that bad. Maybe it's better than Canada for now. I was talking to them before. Anyway, thank you very much for the opportunity. And I've been in every mining space summit or space resources week since from the beginning. Unfortunately, we can't come now, but hopefully in the next couple of years, we'll go back to Luxembourg. So I'm quite excited for that. So I'm going to talk today about the drivers and impediments of potential technology transfer between mining and space sectors. So it's actually, Joseph said that we're going backwards, but actually I will bring back to the future you guys. So let's talk about that. And okay, sorry, just give me a second. Okay, so okay, you can see it, right? Sorry. Okay, it's just a start. What I'm gonna start talking to first, I will highlight a couple of critical technologies for the mining industry, and we'll talk about the space later. So the biggest one of the critical technology in mining is obviously exploration. But in nowadays, the technology is moving to advanced exploration techniques and imaging technologies. But we have to, when we extract the minerals, we break the rock and then extract the minerals using the processing technologies. And it's happening, right? Okay, so I can only see the small screen. And rock breakage technologies, when we talk about rock breakage, is about rock cutting technologies and drill and blast technologies. And productivity comes from the equipment and the equipment utilization, which nowadays mining industry is moving to autonomous systems. And materials handling, simply loading and haulage activities in the mining using the technologies. And sensing and communications technologies, simply the monitoring of the operation, which is becoming much more important with the technologies on IoT industry, Internet of Things, but now we call it Mine IoT, MIoT. And obviously we need to create the value add using the processing and beneficiation technologies. But one thing that people generally get confused about the technologies, we're not talking about technologies only the equipment or digital technologies. So the procedures and regulations also considers in definition of technology also considers as the technology. So therefore the risk management, I would put the risk management procedures and approach as part of the technology, critical technology in mining, which we really excel. And next critical technologies, I want to talk about the space industry's critical technologies. And there are plenty of them. I'm not the real space expert yet, but systems architecture, systems engineering approach, they are quite critical for the space industry. And the communications and navigation systems are quite important, but must be constant and remotely controlled. And robotics, and of course, important the advanced materials, lightweight and high strength materials, and the propulsion systems in terms of power, heat shield, and radiation protection. You can add many, many more critical technologies. And why are we talking about technology transfer? Why we think these two industries really find a link? So what's the necessity of doing this? So I guess the necessity is the common challenges. So both industries working on the extreme environment and then with the excessive risks. And exploration and prospecting, this is a terminology difference or problem between the two industries. I'm not going to go in detail. I think some of the speakers already talked yesterday and the day before, and it's been covered in the course as well. So the exploration is the common challenge, and autonomy, as well as together with the human intervention and involvement, is quite a big challenge for both industries. So, can you hear me? All right, I think it's okay. So power and water, both producing as well as the using power and water are the both challenge for the both industries, and infrastructure and logistics are the common challenges as well. And both industries have to operate in the high investment and operate in an environment with high investment, requires high investment and high cost, both capital and capital cost, specifically capital cost. And so let's talk about the future of the mining industry. So mining industry is really looking at to achieve zero entry mines, which is also called precision mining. The meaning is mines are operating without human involved in the operation itself. So this is called zero entry mines. And the next one is the invisible mines, which aiming to reduce the environmental footprint, which generally considered as underground mining or in situ mining systems like in situ leaching techniques. And social acceptance, we have to improve the social acceptance, improve the reputation in mining in the community. And the other important things, the energy and water efficiency, we need to improve the use of energy and water efficiency, which is quite critical. That's what we aim. But also mining industry, the future would definitely consider the reducing the costs. This is very critical. I'm sure Gavin would have been talking about this previous speaker. He couldn't turn up today, unfortunately. So if you look at the space industry, which I'm not going to talk about space industry's future, but I can talk about the space resources industry's future. So I think is the most important aim is settling in space, which is developing the colonization, achieving the colonization in space. The next big thing is about reduced investor risk. So I think all of us are trying to reduce the investors' risk to create a market. Actually, to do that, we need to develop technologies that we can extract resources in space, which is space resources utilization. I think it's what we talked about in this week, all this week. So obviously, the other most important thing, which is really need to be developed in the future, to establishing legal, ethics, and standard regime to achieve this. And if we talk about a little bit more detail about the regulations and compliance and standards, I think it's already been covered. And mining really well established the safety regulations and standards. And we also established the environmental management through sustainable mining practices, which we aim to achieve the social license to operate to conduct our operations. And risk management of procedures also well established, as I mentioned previously. In space, actually space, as I also mentioned, a well-established space systems architecture and ConOps and systems engineering approach. So the security is the next big thing, which is quite important for space resources. Now the space development really is transitioning from the discovery phase to the security and commerce phases. So defining the really security of SSH space will be quite important in the future. And this can be divided, as the scrolls said in the paper, space for security on Earth and the safeguarding of space for peaceful endeavors in the future operations. But the important thing we need to consider, the industries, manufacturing industry and mining industry already achieved the industry consolidation. So I believe in the future, especially in related to space resources industries, miners will consolidate with the equipment, technology, and service companies. I just gave an example by considering Gavin is talking before me. So I put the Rio Tinto's logo there. So Rio Tinto's assets is about $80 billion and Google is around $1.4 trillion. So big fish can eat the small fish, or sometimes could be vice versa if Rio Tinto starts the space mining actually operations. But if the Google purchases Rio Tinto or a mining company, or Amazon can purchase a mining company or something like that, so this consolidation can really lead to globalization, which is happening in other industries as well. So most of the large companies nowadays is really going through the globalization, which will happen in space resources as well. So the other important thing which I haven't touched at the uncertainties, uncertainties really, in mining is mostly coming from geology and resources, defining resources and reserves. Resources are potentially economic, but reserve must be economic in mining definition. What you see here in the left-hand side, the NASA Systems Engineering Handbook for the project management purpose, and the right-hand side, you see the project development phases in mining. Typical mining projects start with the exploration, resource definition, evaluation, and construction, and the production and the closure. So the whole concept here is the increasing the certainty, which is really increasing the value as well by all these studies. So this is quite a big difference between mining and space, because the mining is really focusing to create the value. And coming to the technology transfer between the disciplines, industries, so from mining to space, and then we'll talk about the space to mining. So mining to space, drivers and impediments. So the driver, one of the biggest driver is the knowledge in the production capability, and knowledge of extraction and processing technologies in mining could be a big driver to take these technologies into space. And also mining has a big experience in operating in high capex and high investment risks environment, and also market development and knowing, creating the value from the project, which using the project valuation techniques. And also having the experience in business decision making is quite a big driver to transfer technologies from mining to space. Sorry, I forgot to click, sorry. Yeah, and then impediments. In terms of impediments, lack of data is impediment in both mining to space and space to mining, and also lack of technology showcase in mining to the space is we don't have spin-off technologies which we can deliver to space from mining, and also size do matter because big is not always better. So specifically, moving from mining equipment, we got large equipment, we can't really use them in the space resources. And the biggest impediment is also reputation of mining. And the next one is high capex. I said could be a driver, but in this case could be an impediment as well. So looking at the space technology, what can we deliver in space and from space to mining? So looking at the drivers, as I said, we didn't have any space mining technology spin-offs which we can use in space, but there are plenty of spin-offs technologies we already use in mining industry. And the next one is the reputation of space is quite well accepted in mining, and this using the space technologies can improve social license to operate in mining and increase productivity and reduce operating costs with the high technology transferred from the space using the autonomous systems and robotics, and also systems approach adaptation, which is the big thing we talk, and also very well achieved international partnerships in space could be a big driver for the technologies transferred to mining. Looking at the impediments, mining is under technology transformation, and potential higher capital expenditure technologies, high technologies, generally being miners generally being impatient for the learning curve period for the new technologies. This could be quite a bit impediment, and also answering the good to have it versus necessary in technology management, technology implementation is sometimes failing in mining industry. And then in high risk technologies, like miners really like to be first to be second. This is quite important. Proverb we use in mining. So this is a big impediment, any technology implementation. And what I said in driver international partnership, it could be also impediment, because international partnership, considering lack of governance and also considering geopolitical issues, could be a big impediment as well. So looking at the conclusion, I couldn't really hold the time. I hope I did well. And sorry, Joseph, if I talk too much. But in terms of conclusions, there are very mutual benefits for the both industries. Actually, I already highlighted these. And the industry industry consolidation will happen. I believe that it is inevitable, according to my opinion, and I don't know how. And don't get me wrong, I know nothing about purchasing Google to Rio or vice versa. But I'm just giving an example. And international partnership is the key for the success, but also it's more a little bit of our I think, our role in universities. Research and development we do well, but what we fail generally, demonstration and deployment, which we call it RD3. So once we do generate the rapid commercializations, I think is the way to go for the success. Thank you very much.
Serkan, thank you so much. Always a pleasure to see you and hear from you. Over to Joseph now. We've had a lot of questions coming in. We are going to try to stick to time. It's been difficult this week because everybody is so interested in what you have to say. So a lot of questions. I'm sure you can pick a couple from the list coming in.
Yes, of course. Serkan, you're still on time, but well, keep your answers to our questions a little bit shorter, then we will be fine, I think. So we had several questions, especially Jerry Sanders, who we know well, was very active. I think his first question was more for the next session for financing and business models, so I will forward that to that session. His other question was, how can space technology help zero entry, zero emission goals? Do we have an answer for him?
Yeah. Look, zero entry means that no human involves in the operations itself. There is no people in the mine. So all these autonomous systems achieved in space and communications, navigations, which I gave examples, and robotics use, I think it's the way to go. I mean, and precision mining, which I'm working currently on this, I can't reveal too much in details, but using the small equipments and very small micro level equipment to produce the minerals in underground can create the zero entry mines. So what I'm saying that the mines will be operated from the remote operation centers, which is sort of happening, but still our mines are still the size of the human can fit. What I'm talking about, it's like really precision mining using these small equipments to extract small minerals, the gold, like if you look at gold and copper, we are after 1 gram in 1 ton. So what I'm saying, if we achieve the zero entry mines, we should really target 1 gram, not 1 ton. This will also solve the environmental issues. Thank you.
Thank you, Serkan. Another quick question from Joao Carvalho. What exists in terms of estimated space resources in the Moon or Mars in terms of mineral potential mapping and resource estimates? Where can you find information, data, or maps? That's probably a very difficult question.
Yeah, there is no one, probably Carlos Espejo from iSpace can answer this question. I'm sure he covered this in his course. Look, it's very hard because we don't have data. And that's why, advanced exploration, imaging technology, we looking at the terrestrial operations as well must be the key. Sorry, but I can't answer that question.
We just got another question. This may be interesting, especially as we unfortunately don't have our first speakers. Given the apparently obvious benefits to mining industries, why are we not seeing major players such as Rio Tinto, Alcan in the lunar mining game?
Yeah, I think I answered that question already. Miners like to be first, to be second. So, I wish Gavin would have been here to answer that question, but I'm sure he would have said the same thing. Or we should wait Google to buy Rio Tinto or Anglo American or BHP.
Any tips how we can convince them to take the leap?
Yeah, Joseph, you know that I have these tips, but it will take hours to talk about that.
Okay, thank you, Serkan.
Great pleasure.
To the next talk, Lisa, please introduce the speaker.
Wonderful. Thank you very much, Serkan. Lovely to see you there. And hopefully you can dive back into the chat yourself. Now you've relaxed after your own talk and enjoy the rest of the session and perhaps reply individually to the many questions that have come in for your talk. Now.